Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about how to simulate the null hypothesis when comparing two group proportions. We will use the Swimming with Dolphins data to talk about this learning goal. We're going to apply the 3S strategy to the Swimming with Dolphins data. Now, the statistic of interest is the difference in the two group proportions. 0.67 minus 0.20 gives us a difference of 0.47. The second S of the 3S strategy is simulate. We want to simulate the null hypothesis of no association, that is, equal probability of success in each group. How can we do this? We can't just flip a coin anymore. Instead, we'll talk about how to use card shuffling to simulate this null hypothesis of no association. To do the simulation, you can take 30 index cards. What we'll do is we'll have some of those index cards be blue to represent people who substantially improved on their depression symptoms, and some of the index cards green to indicate that a person did not substantially improve on their depression symptoms. So we're left with our 13 blue cards and 17 green cards. Now, if the null hypothesis is true, then the improvement is not associated with the group you're in, whether or not you swam with dolphins. Stated in terms of the simulation, your chances of improvement, that is the card color, are the same in both groups. So how can we simulate this? If we shuffle the 30 cards and deal them into two stacks, one stack representing people who swam with dolphins, another stack of 15 representing the people who did not swim with dolphins, then we will have simulated the null hypothesis. Take your index cards, some blue, some green, representing values of the response variable, shuffle and deal them into two stacks representing values of the explanatory variable. Find the statistic, repeat this many times. Let's show you this in the applet. I've gone to the two proportions applet on the ISI page and I've entered the data here for this study. If I click Show Shuffle Options, you'll see that I start with 10 blue cards in Group A and 5 green cards. So Group A here represents the group who swam with dolphins. 10 successes, 5 failures. Success here is showing substantial improvement on your depression symptoms. In Group B, the control group, there's only 3 successes represented by blue cards. If I click Shuffle, you can watch the blue and green cards be shuffled and dealt into two stacks. Now, in this shuffle and deal, I'm left with 4 blue cards in Group A and 9 blue cards in Group B. From this, we can compute the difference in the success proportions as negative 0.33. To get this, you take 4 divided by 15, the Group A success proportion, and you subtract 9 out of 15, the Group B success proportion. You'll notice also over here in the graph on the right, we now have a dot at negative 0.33, indicating the value of the statistic for a single simulation. Of course, the great thing about using the computer to do these simulations is that we can quickly do many of them. So I'll click Shuffle again. We'll watch our 30 cards get shuffled and dealt into two stacks. In this case, we have more successes in Group A than we do in Group B, so we have a positive difference in proportions of 0.33. We can continue to click Shuffle and deal and get more differences in proportions. We can also then change the number of shuffles to get many differences in group proportions. We now have 1,000 simulated values of the statistic, the difference in the group proportions, when the null hypothesis is true. A few important words of caution. In these simulations, we typically let the card color represent the response variable. In this case, blue meant showed improvement and green meant did not improve. The stack the cards were dealt to represented the values of the explanatory variable. Now, as it turns out, if you reverse those, it actually doesn't matter, but we feel that it models the actual study better if you keep the card color representing the response variable and the stack you deal to representing the explanatory variable. Make sure when you compute the statistic that you subtract in the same order. So when we initially computed the statistic, we took the proportion of successes in the Swim with Dolphins group and subtracted the proportion in the control group. You need to always do the subtraction in the same order. Some students sometimes make the mistake of always making their statistics positive. We want to make it so that it's equally likely that you're greater than 0 or less than 0. In that case, your null distribution will take a bell-shaped curve centered at 0. Later in the course, we will look at what happens when you make your statistic always positive. But for now, we're going to always do the subtraction in the same order. Another important point. The stack size, or the stack you're dealt to, is going to represent the group size. Now, in this example, there were 15 people who swam with dolphins and 15 who didn't, so the group sizes were the same. That will not always be the case. They may be unequal. Very common mistake for students is to try to make those equal. Make sure that your simulation matches the study. Some students wonder, how is this modeling no association? Well, if there's no association between the group you're in and showing improvement on depression symptoms, then the card color, representing improvement, is not related to the group you're in. So if you shuffle and deal, you're saying that the card color has no relationship, no bearing on which stack the card gets dealt to. That's why we're simulating the null hypothesis. Another question students sometimes ask is, well, why are there always 13 improvers? In other words, why do I always have 13 blue cards? Well, if the null hypothesis is true, then the 13 people who showed improvement on their depression symptoms improved for some reason other than swimming with dolphins. For example, they flew from, let's say, cloudy England in winter down to Honduras, where it's sunny, and seasonal affective disorder and other sort of types of depression are very much impacted by the amount of sunlight you get. So that could be an explanation for why there's 13 improvers, even if the null hypothesis is true.